Welcome to another video episode on my Arduino Yun. Running embedded Linux with a graphical interface as well as with USB storage, which comes in handy for data acquisition, which I do with all the electronics and some fischertechnik mechatronics. Lately I have been busy with an attempt to get some nice graphs from Octave mathematical software by storing data, copying it over the internet, over local network I should say. That was this one, screwdriver for the potmeters. Anyway, copying and then importing into Octave, and then with the matrix trying to get a nice graph. However, there are some other things that I want to do. First of all, here I have two buttons that do work. I also have two buttons here, and they are less likely to work because for some reason they jump out of their well, let's say gates, sockets. So let me press this one. Yep, that works, and immediately this let's say this is rather short-legged, but it should be there. Let's try to put it back into its place. Yep, still working. This one as well. With the exception that this one is dependent on some other stuff right here, and that I haven't seen this work for some time. So most likely a nice idea to focus on this. So first I need to get some data into the console, remove all data, and then say okay, I give some data. Now here is one thing, this gives power here, but this one doesn't do a thing. So let me add this LED. Now I have to make sure that I put the correct side in, because there's a plus and a minus, and it is a bit hard to see which one is which. And then it turns out that I should use it like this, so I put it in here. Would this make a difference? Because the red is a bit hard to see, as it proved time and again. So let's see how this works out. No, nothing. Alright. Well, this is working, so this one gets some feed. And then this one is working, so that is alright. So let me change this one to here. This is the fourth probe. So now it's time to change to screencast and see how this works out on scope as well as with the other ones. Alright, so concentrating now on this part. No data yet. or anymore, so I will remove this part. I will give some data here and then concentrate right here, because this probe is this line, so this line. Let me check. Yes, it's pulse width modulation. So as you can see here, the signal is rather wide, which implies that towards this capacitor it is quite big. So in that respect, when I press this switch here, this button, this one should light up. Does it? No, it doesn't. Nothing happens. So let me move this one right here. Oh, I see a difference, by the way. Here there is a resistor after the LED. Here there is no resistor after the LED. Neither is here, but this one works. So this one should work too. And once again, yeah, it should work. Let me try for does this one work? No. Does this one work? And now I've turned it around again. Yeah, now it works. Alright, so now this one works, this one doesn't. So the question is this LED correct? I can't say for sure, but the fact that I now press this button, you should see a short flash. No, you don't. I don't see it either. I should give it some time to charge. Also, the signal has gone to 0. Yeah, you see on the oscilloscope here signal change. And you see that this LED lights up. Well, okay, that's a problem. I see it light up. On camera you can't see it light up, unfortunately. Don't ask me why. So let me reduce the light. Can you see it now? Yeah, now you can see it. Okay. So that does work. Nice. And this one should work as well, of course. Now I will give again some data. And then would this work again? No, it stops the motor. It stops this motor. I am now very carefully, slowly turning the spot meter back and forth. but now this LED doesn't want to burn. Alright, so one thing solved, with a big question if this LED is good. This one works, so that's good. What to do next? Very good question. I am not quite sure anymore how I should read this one, because originally when looking at fischertechnik examples, there's a lens lamp that burns, but that lens lamp is controlled by 9 volts. Here I do not have 9 volts, so it's futile to try that. I could do that, by the way, using once again the power controller and have it burn. But then it would be something outside the circuit, and that's not really my intention. So let's see how this goes. Will be a lot of zeros again, but we'll see. Alright, yeah, starting with some zeros, and then in between, oh yeah, right, this is something that I should analyze and get rid of, because these are, yeah, let's see, no, in that one, this one. Let's put this one right here. And this is for 1000. That means that it is for this one, for this part of the code. Because here I go with 1000. Then I have, oh wait, that is time. It's not any button, it is a time. And that means wait, I forgot to do something else as well. I forgot to set the time to today. Because now if you look here, ouch. Can I do this somehow without the user interface, the graphical user interface? Let me check. Sudo is not necessary because I am root. Minus H. Yeah, I can. So minus S minus, what is the difference? Oh, D is display and S is set. So I need S, and then getting 2018 10th month. Oh, that doesn't go right. 10th month, and oh wait, I should do a different dot, and the date is 9th dash hour 10 column 49. Would that work at all? Yeah, it works. No, that would be 10. Alright, so I don't need the graphical interface anymore. It's this one. So let me remove this data log, although yeah, that weird number is time since the start, so I can forget about it. And then no, not that one, this one. Give timing. Go to the end, here we come. Alright, and then another thing, this will be time as well, and then I have alright, looking at 1000, it is 1000, it is time and a sensor value. This doesn't make sense anymore. This command, output value, which is not a button anyway. Oh, it is a button. Wait, 02 is a button. Right. So this one is a button. In this case. And then I have a sensor value, true. Output value and C value. But did I... Oh, then I have another question. When did I press a button? When did I press a button anyway? Oh, that's an interesting one. Because this is for the first button, which is this one. This is 2 and 2A together, but this is the first button. I can't recall pressing the button. Okay, that is interesting. Remove. Give data. And alright, I wanted to press the button, but I rather have it like this. Looking at 1000. And here it already says there's a button pressed. I'm not pressing the button right now. I am not pressing a button. And here it says 1, here it says 0. So, what's wrong with that one? Does this wire does some evil work? No, because it's still doing things. Here again, and I'm clearly not touching it. 0, 1, 2. 2 is the button. I can also do what? Sensor value switch. Which is the sensor value switch again? Okay, that is digital in 5. And that one goes from here to here. Then this one goes to here, which is indeed 5. Okay, you did not see me do it, but this one from this button goes here, then this wire goes here, which is number 5. So that is indeed the one that I am using right now, which tells me that there is something odd going on. How can that button be 0, be 1 when it's not being pressed? Not good. Alright, before going any further, I solved some annoying thing, which is right here. Let me shine a better light. This one was giving quite some trouble with these rubber parts which got stuck behind the lamp. I mounted, and I hope I can shine a better light on it, right here. Oh, that's a miserable light, but maybe I can turn it this way. Alright, now you can see it. I put a little piece of material here, of course also fischertechnik, and now it guides it nicely over the lamp. Simple but effective, and no more hassle guiding it by hand. Then still the mystery of this button. I checked once again the wiring right here, and let me do it like this. The wiring here, it is in pin 5, not 6, so when I check right here, 6 is to a transistor and 5 is, where have I got 5? Right here. And then this is indeed that switch 1. So it's still doubtful how that works, why it is 1 against nothing. Oh yeah, why do I remove the data log file? Because of the fact that it, without any console data, it gets zeros, as you can see here, all zeros, and then it starts working. And time has gone on, as you can see. And it goes on even if I don't do anything and have to search on. System is on, the Arduino Yun is powered on. So time goes on. So in that sense, it is certainly not an ordinary computer. And yes, I can do this, and then I know that quite some time has elapsed by now, as you can tell here. But each time I remove power, time is set back to 2015. So be it. And there's also not a real location that you can put a memory battery in it. So it's well, it's a computer, but not an ordinary one, obviously. What next? Okay, it's in storage. I have Octave here, and I still have to do some stuff for having more data. So now I'm generating some zeros and once again some data. Time to generate some more stuff. I don't care about the buttons right now. And now I need this one to turn around, which I finally manage. This one has to go right here, and you can see on the oscilloscope the operator lines going up and down. Alright, so now I hope that I have some nice input consisting of 1000, 1001, 1003, 2, 1, 2 and 3, that is. So let's go to the end. Yeah, 1000, and I have everything here. 1000, 1001, 1002 and 1003. So, quitting this one. I have to open another one. Let's do it in a tab. Secure copy. Root at IP address. Mount and data log dot text right here. Alright. That's it. Not a very large file. Then I go in here, and all I should do is alright. This is an iData file. And now the question is, of course, which I did last time as well. How do you find everything you need? Like, you want the plot file, but you also don't want the zeros. So then you end up with something like this, although you have to define it. So first, this one. Oh, I forgot. It has to be this one. Column 1. And I have to be in here. And then for example, right here, this one. So these are all the entries without that are non-zero. And now the question, which is which? So, what is this one? 1000. So, if I look at this one, no, this one. At the start, then I know that the next one is 1002. So that should be 2. No, not this one. This one. Yeah, that's correct. Now you see also that the same line, but next character gives the timestamp. So now the big question is, where do I find 1001, for example? And that is way below. So the point is, how do I find it? If there's something equal, and I did it, I tried to do it last time, didn't manage, didn't have time to find it out really. So I have to leave it at that for now, because I also see that time is running out. So I'm afraid that's it for now. Some more data. So that's it for now. Thanks for watching. Let's do a short recap. So I checked this RC circuit, I checked that one, and this one, that one should have the button replaced. This one has still some vague 1 instead of 0 when it's not pressed. And I fixed this problem. So this is a new guide to guide these rubber shields. Well, they are actually not shields, but acting like one to shield light from the phototransistor. So thanks for watching. If you like this video, please subscribe to my channel. Give the video a thumbs up. Like it. Yes, I put the pot meter in a nice setting and then hit the console for more data, so it starts running. Leave a comment or a suggestion with the video, please. You can also follow me via Twitter and Instagram, and I would appreciate a donation for some support. All voluntary, all enjoy the discussion, but very much appreciated. You can also become a patron and have your name mentioned on my website and or with the video. So, thanks for watching, to be continued, and bye bye.